The next question is that I is equal to integral 2 to 6 mod x minus 5 dx. Okay, this is mod here. Whenever you see a mod, okay, whenever you see a mod, first try to break it up. Okay, what do you mean by mod? Here, mod x minus 5, for any mod function, if you remember, I had told you that for any mod function, mod x minus 5 is greater than or equal to, in fact, mod x minus 5 is the same as x minus 5 if x minus 5 is greater than or equal to 0. Do you remember this? Is equal to minus x minus 5 if x minus 5 is negative. Do you remember this or not?
Yes, sir. Yes, sir. This one I remember.
Do you remember this rule? Mod x
Yes, sir.
is equal to
Yes,
x
sir. Mod.
for x greater than 0, greater than or equal to 0 is equal to minus x for x less than 0. Do you remember this rule?
Yes, sir.
The same rule we have applied here, but instead of x, we have replaced x by x minus 5. Okay.
Okay, sir.
Amir, do you see
Yes,
this?
sir.
Do you understand?
Yes, sir. Yes, sir.
Okay. So now this is mod x minus 5. From here we can write is equal to x minus 5 for, in fact, this also will be for, and for x minus 5 greater than or equal to 0. What does it mean? It means x greater than or equal to 5 is equal to minus of x minus 5 for x less than 5. Fine.
Yes, sir.
Now we shall evaluate. Now see, therefore I is equal to, what is the given integral? 2 to 6 mod x minus 5 dx. Now see this integral, you see 5 is a point here, right? Isn't it? 5
Yes,
is a
sir.
break point here. For a x
Yes, sir.
greater than or equal to 5, you have one value, and for x less than 5, you have another value. So 5 is kind of break point
Yes,
here.
sir.
So what you do is you change this to 2 to 6 can be taken as 2 to 5 mod x minus 5 dx
Yes, sir.
plus, and then from 2 to 5 you go, and then you go from 5 to 6 mod x minus 5 dx. Right? Is this okay?
Yes, sir.
Do you understand what I said? Amir,
Yes,
Yes,
sir.
sir.
understand this very well. 5 is a break point, and where, remember, 5 lies between what? The two limits, 2 and 6. What are the limits? 2 and 6. And
2
5
and
lies
6.
between 2 and 6, right?
Yes, sir.
Isn't it? So therefore, if you remember this rule, property number 2, this one, integral a to b fx dx is equal to a to c fx dx plus c to b fx dx, where c lies between a and b, right?
Yes, sir.
So we have used that rule here. Now we shall evaluate the integral. Now see, integral 2 to 5. When x is between 2 and 5, what is the value? When x is between 2 and 5, what is the value here? Should it be positive or negative?
Positive.
Sir,
2
positive.
and 2 and 5 both. See, 2 and 5 both. The 2 and 5 both are less than 5,
Two.
right? 2 and 5 both are less than 5. So which one will you take? We'll take minus
Yes,
x
negative.
minus 5, right? Plus,
Yes, sir.
again,
Yes,
5
yes.
and 6 both are greater than 5. So which value will take? We'll take this value. 5 to 6, x minus 5, and then dx. Now we shall evaluate very easily. This becomes very easy now. You take the minus sign outside, x minus 5 dx, okay, plus, give the limits 2 to 5, come 5 to 6, x minus 5 dx is equal to minus. Now you take the integral inside, integral x dx minus 5 integral dx, and this has to be evaluated between the limits 2 to 5, plus integral x dx. And so see, instead of giving the limits in the integral, I have given it outside the bracket. Okay. See, if you don't have any
Yes.
problem with this notation, tell me if you have any problem.
No, sir.
Hello.
Yes.
Hello. Yes, sir.
See, Govinda, see this step, whether you have any problem with this notation.
Sir, can you explain once more?
Which one?
Second. Sir, the last second one.
Yes, I've evaluated this as a definite integral, this as a definite integral. See, you distribute the integral over x, you get what? X dx, and then you have 5 integral dx. That's what I've done. And again, this one
So
is
then after that,
integral x dx, and then you have a minus 5 integral dx. I've just distributed the integration.
okay, sir. Okay, sir.
Okay, so this one is half of x square minus 5x, and this has to be taken between the limits 5 to 6. Now it's done almost. Now put the upper limit, minus half of 5 square minus 5 into 5. Now put the lower limit. And when you're putting the lower limit, just insert a bracket here.
Okay, sir.
Okay, so that takes care of this part. Now we come to this part. So plus half into 6 square minus 5 into 6 minus half into 5 square minus 5 into 5. That's it. If you evaluate this, if you simplify this actually, okay, if you simplify this, you're going to get this as 9. I'm just writing the answer. You do the simplification later. Understood? This is how we do mod
Yes, sir.
sums. Okay. Let us do another one, another mod sum. All this has come in your IC. Problem. Let I is equal to integral minus 5 to 5 mod x plus 2 dx. Okay. So now how to do this? So we have mod x plus 2 is equal to x plus 2 for x plus 2 greater than or equal to 0 is equal to minus x plus 2 for x plus 2 less than 0, right? That means you have mod
Yes,
x
sir.
plus 2 mod x plus 2 is equal to x plus 2 for x greater than or equal to minus 2 is equal to minus x plus 2 for x less than minus 2. Fine. So
Yes,
now, therefore, what is I? What is the breakpoint here? Breakpoint is minus 2. So we'll take the limits from minus 5 to minus 2 first, right? And then we'll take the limits from minus 2 to 5. See whether the limits are clear to you. Now see, minus 5 to minus 2. Okay. For minus 5 to minus 2, which value should we take? From minus 5 to minus 2. Is it greater than any value between minus 5 and minus 2? Is it greater than 2 or less than 2?
-5.
It is less than 2. So
Sir,
we'll take
yes, sir.
less than 2.
minus x plus 2 here, dx, right? And you'll give the limits minus 5 to minus 2. Again, plus minus 2 to 5. Any value between minus 2 to 5 is greater than minus 2, right? Greater than or equal to minus 2. So this time we'll take this value, x plus 2 dx. You give the limits minus 2 to 5. And how to evaluate this definite integral? So this is minus of integral x dx plus 2 integral dx evaluated between the limits minus 5 to minus 2 plus again integral x dx plus twice integral dx evaluated between the limits minus 2 to 5. So this is minus half x square plus 2x plus half x square plus 2x. Okay. And the limits here are minus 5 to minus 2. Here the limits are minus 2 to minus 5. Now you put the values. That is minus of, first you put the upper limit, half into 2 square, half into minus 2 square plus 2 into minus 2. Okay. Minus the lower limit, half into minus 5 square plus 2 into minus 5. Okay. And for the second one again, same thing. Put the upper limit, half into minus 2 square. Lower limit is minus 2 plus 2 into minus 2. And then you close the box bracket also. Okay. And you simplify this to get 29 as your answer. Understood?
Okay, sir. Yes, sir. Understood.
Let us see the
Yes, sir.
next one, another mod problem.
Okay, sir.
minus 1 to 2 mod x by x dx. This integration. Now again, what do you see here? You see a mod. So again, you write the way you write your mod. So we have, what is the value of mod x by x? For x greater than or equal to 0, it is equal to x by x. For x greater than or equal to 0 is equal to minus x by x for x less than 0. That means mod x by x is equal to 1 for x greater than or equal to 0 is equal to minus 1 for x less than 0. Am I right?
Yes, sir.
So therefore,
Yes,
what
sir.
does I become? Therefore, I becomes, now what is the break point? 0 is the break point, right? So this
Yes, sir.
will go from minus 1 to 0, mod x by x dx, and then we'll move from 0 to 2, mod x by x dx. Now between minus 1 and 0, from minus 1 and 0, is it any value between minus 1 and 0? Is it less than 0? Yes. So we'll take minus 1. So this is minus 1
Sir.
dx. Any value between 0 and 2, is it greater than 0? Yes, it is greater than 0. So we'll take 1. That's it. Finished.
Yes.
The minus sign outside. Minus 1 to 0 dx plus integral dx. And this is minus, again integral dx is x, values taken between the limits minus 1 and 0, plus x, and this limit is 0 to 2. So x taken between 0 to 2. So this is minus of 0 minus of minus 1, right? This is minus of 0 minus of minus 1 plus 2 minus 0. That's it.
Yes, sir.
Is equal to 0 plus
Yes.
1 plus 2, which is equal to 3. That is the value. Okay. Let us take another one.
Yes, sir.
And this type of problem is important also. I feel that if I was there, if I was setting the paper this year, I would have given this problem. Question is, evaluate integral a to b fx dx, where fx is defined as fx is defined by fx is equal to sin x if 0 less than equal to x less than or equal to pi by 2. Okay, is equal to 1 if, so for various values of x, you have different values of fx, right? Pi
Yes.
by 2 less than equal to x less than equal to 5. And you have e to the power of x minus 5, e to the power of x minus 5 if x lies between 5 and 9. Okay, so see, what are the intervals here? The first interval is 0 to pi by 2, and the value of fx in this interval is sin x. Next interval is pi by 2 to 5, and the value of fx in this interval is 1,
One.
and the next interval is 5 to 9, and the value of fx in this interval is e to the
To the
power of
power x minus
x
how much?
minus 5. Okay, so therefore we start by saying integral a to b fx dx. This is not a to b, the question was integral 0 to 9 actually. Copied it wrongly. Evaluate integral 0 to 9. 0 to 9. So therefore we start by saying integral 0 to 9 fx dx is equal to, now see that the lower limit is 0, and the first and the lowest here interval, the value here is 0. So therefore we write, first we'll take from 0 to pi by 2 fx dx. Next from pi by 2 to 5 fx dx. Next from 5 to 9 fx dx. Check whether this step is clear. See the question and check whether this step is clear.
Hmm. Sir, can you explain once more?
See, what are the intervals? What are the intervals you can see here? First interval you see here is 0
Sir,
to
three intervals are there.
0 to pi
Yes,
by
sir.
2. So I've taken the first integral is for the first interval. Next pi by 2 to
Pi
5.
by 2, 0.
The next integral is for the next interval. And what is the third interval? 5 to 9. So the third integral
Yes,
is
sir.
for the third integral, right? Now
Yes, sir.
understood.
Yes,
Yes,
sir.
sir.
So now we'll put the values of fx. Let's see what are the values of fx for the various value. From 0 to pi by 2, what is the value of fx? Check what is the value of fx between 0 to pi by 2. It is sin x, isn't it?
Yes, sir.
From pi by 2 to 5, what is the value of fx? It is 1. And from 5 to 9, what is the value of fx? E to the power of x minus 5 dx. Now check once again. Now this looks like a very long kind of problem, but it is actually a very easy problem. Check whether you have understood this. For the first interval, what is the value of sine? What is the value of fx? Sin x.
Sin X.
Yes, sir.
For the second interval, between pi by 2 to 5, what is the value of
1.
1?
1.
And for the third interval, what is the value?
E to the power x minus 5.
Power
That is what
minus
I have
5.
done. According to the limits of the integral, I have put the value of fx.
Okay, sir.
Now we shall evaluate the integral. This is finished. The integral of sin x is minus cos x. You take it between the limit 0 to pi by 2. And integral dx is simply x. You take it between the values pi by 2 to 5. And e to the power of x minus 5 is e to the power of x minus 5, taken between the limits 5 to 9. Right?
Yes, sir.
So how to evaluate this now? Let's see. If you change from cos x, from minus cos x to cos x, what happens? You change the limits, right? Pi by 2 to 0. Or you can also take the minus sign outside, no problem. You want to check whether you understood this step. Check whether you understood this step. If you remember, I had told you that if you have a minus inside, minus phi x taken between the interval a to b, then if you remove the minus sign inside, then you can interchange the intervals. If you remember, I had told you this at the beginning of definite integrals. You remember
Yes,
this
sir.
rule?
Yes, sir. You have said in the beginning.
In the very beginning I had said this.
Yes, sir. Yes, sir. Yes, sir.
So that is what I have done here.
Okay, sir.
This is 5 minus pi by 2, and this is e to the power of 9 minus 5 minus e to the power of 5 minus 5. Okay, so this is cos 0 minus cos pi by 2 plus 5 minus pi by 2 plus e to the power of 4 minus e to the power of 0. So cos 0 is 1, and cos pi by 2 is 0, plus 5 minus pi by 2 plus e to the power of 4 minus 1. So what happens? Again, 1 cancels here. This 1 plus 1 and this 1 cancels here. So what do you get? You get
Yes.
5 minus pi by 2 plus e to the power of 4. That
Plus
is
e to the power 4.
that is the value of the integration. Okay. So that completes all
Yes, sir.
your most of the modulus problems. Okay. Now one modulus problem, in fact, this is a tough one. So maybe I'll keep it for later. Or maybe I should do now. Let me discuss now. So that next day I can discuss the next important property. So we have the problem here is let I is equal to, because because most of your students of class 12 and especially commerce, they have a lot of problem with mod function. Mod function is a big problem for them. Dx 0 to pi by 2 mod sin x minus cos x dx. This is the problem here. Okay. So again, write the mod function as it is. So we have sin x minus cos x mod sin x minus cos x is equal to sin x minus cos x for sin x minus cos x greater than or equal to 0 is equal to minus sin x minus cos x. Now check this step if you have understood. For sin x minus cos x less than 0. Check whether you have understood this step. Any
Sir,
problem
the
here?
first step will be sin x minus cos x will be greater than 0, and second one will be less than 0, no?
Yes, because that is why
Okay, sir.
because this
Yes,
is
sir. Yes,
greater
sir.
than or equal to 0, I have a plus sign here.
Yes, sir.
Yes, sir. Understood.
Now that means this means mod sin x minus cos x is equal to sin x minus cos x for sin x by cos x greater than or equal to 1. Can I write this? See, from this inequality, what can you write? You can write sin x greater than or equal to cos x, right?
Yes, sir.
Next, you can write
Yes, sir.
sin x by cos x greater than or equal to 1.
Yes,
Can
sir.
you write? So that is what I have
Yes,
written
sir.
here. And similarly for the second one also.
Okay.
Fine. That means mod sin x minus cos x is equal to sin x minus cos x for tan x greater than or equal to 1. right? Is equal to cos x
Yes, sir.
minus sin x
Yes, sir.
for tan x less than 1, right?
Yes, sir.
Yes, sir.
That means mod sin x minus cos x is equal to sin x minus cos x for tan x greater than or equal to, now 1 is tan 45, right? Or tan pi by 4. Check whether you have understood this. Instead of 1, I have simply written tan pi by 4. Check whether you have understood this.
Yes, sir. Yes, understood.
Yes, sir.
Tan x greater than tan pi by 4 means x greater than or equal to pi by 4. Cos x minus sin x for x less than pi by 4. Right? So for x greater than or equal to pi by 4, we are getting sin x minus cos x. And for x less than pi by 4, we are getting cos x minus sin x. Now what is the given integral? Let's see. 0 to pi by 2 mod sin x minus cos x. Let's rewrite the integral. Therefore, I is equal to integral 0 to pi by 2 mod sin x minus cos x. This was the given integral dx. Now see, what is the breakpoint here? Pi by 4, right? So we take the limits from 0 to pi by 4,
Yes, sir.
and then from pi by 4 to pi by 2. And from 0 to pi by 4, is the value less than pi by 4 or greater than pi by 4? Less than pi by 4. So which one will you take? We'll take cos
Yes,
x
sir.
minus sin x dx plus, and from pi by 4 to pi by 2, the value is greater than pi by 4. So we take sin x minus cos x dx. That's it. So now we can integrate now. This is very easy. Integral
Yes,
cos
sir.
x
Yes, sir.
dx minus integral sin x dx. This
Plus
has to be
derivative.
evaluated between 0 to pi by 4
4.
plus, again in just distributing the integral, okay? Integral sin x dx minus integral cos x dx. This has to be evaluated between the limits pi by 4 to pi by 2. And therefore, what is integral cos x? It is sin x. What is the integral sin x? It is minus cos x. It becomes plus cos x. This has to be evaluated between what limits? 0 to pi by 4 plus, again here integral sin x is minus cos x and integral cos x is sin x. This has to be evaluated between the limits pi by 4 to pi by 2. So now, before putting the limits, get rid of the negative sign. 0 to pi by 4, I write the first one as it is. And because I have two negative signs there, these negative signs, they come outside. Cos x plus sin x. Pi by 4 to pi by 2. Now you can put the values. Put the upper limit first, sin pi by 4 plus cos pi by 4 minus sin 0 plus cos 0. Okay. minus, again put cos pi by 2, put pi by 2 first, plus sin pi by 2, minus cos pi by 4 plus sin pi by 4. Okay, so that's it. Put the values here. What is sin pi by 4? It is 1 by root 2 plus 1 by root 2. Cos pi by 4 is also 1 by root 2 minus sin 0 and cos 0. Sin 0 is 0, cos 0 is 1, right? For the first one. For the second one, you have cos pi by 2. Well, how much is cos pi by 2? It is 0. Sin pi by 2 is 1 minus again cos pi by 4 plus sin pi by 4. So this is, now how do you evaluate this? This is 2 by root 2, right? Minus
Yes, sir.
1
Yes.
minus, this is 1 minus 2 by root 2, right? So 2 by root 2 minus 1 plus 2 by root 2. So this is 2 by root 2 plus 2 by root 2 is 4 by root 2 minus 2. And you can write, you take 2 common, and you can write this as 2 by root 2 minus 1. Now this can be written as, 2 can be written as root 2 into root 2, I root 2 minus 1. So 1 root 2 cancels. So you get twice of root 2 minus 1. That is your answer. Stop here for today.